Okay, so go ahead and open up your packet to page 1. Now, we'll probably only get through about half of 3.1 today, just because 3.1 is a little bit extensive and I don't want to kind of, throw it all at you at once. But we'll see how far we get. All right. So, polynomials. Why are we reviewing polynomials when we're talking about quadratics? Well, a quadratic equation, function, whatever, is a type of polynomial. All right. So when you guys get to Math 3, you'll learn a lot more about polynomials, like pretty much all the different types. But a quadratic is a type of polynomial, just like a linear function is a type of polynomial. Now, what makes a polynomial a polynomial? All right. So, a polynomial is an expression with one or more terms. Now, does anyone know what I mean by terms? So think about combining like terms. Think about what you actually are doing there. Yeah, so for example, if you're looking at the problem we just did, 14x we considered a term, negative 5x squared we considered a term, 8 is considered a term. A term is basically the values between the pluses and minuses. All right, so the pluses and minuses separate them. Now, if the expression has exactly one term, it is called a monomial. So some examples, we could have 3x squared. We could have negative 2x, or we could have 8. All of those are monomials because they're standing alone. That's why you put commas between them, because they're not connected by pluses and minuses. They're just examples of monomials. If the polynomial has 2 terms, it's called a binomial. So that can be something like x plus 2 or x squared minus 4. All right, those are examples of binomials. They have 2 terms. So there's usually one plus or minus separating them. Now you guys can kind of seeing the pattern of how we name them. So what do you think 3 terms is going to be? Trinomial. So 3 terms, trinomial. Trinomials are probably the ones that you see the most of. So binomials and trinomials are probably the ones you're going to see the most of with quadratics. So example of a trinomial will be x squared minus 3x plus 5. It could also be 3x squared plus 4x minus 6. Those are examples of trinomials. Also, these names come from when you have simplified a polynomial to its max. So for example, what we started with would not be the completed binomial, would not be the completed polynomial. We name it based off of what it is after we finish simplifying. So this polynomial would be a trinomial because it ends up with 3 terms when we finish simplifying. Now, finally, if it has 4 or more terms, so once you get past 3, there's no longer a special name for it. You just call it a polynomial. So once you get past 3 terms, it's just called a polynomial. So an example would be x cubed minus 2x squared plus 4x plus 7. So that one has 4 terms, so we just call it a polynomial. So These three right here, those are the ones that you really need to know because I'll be using those words a lot. All right, and again, way to remember it, just look at the root of the word. So mono, that means one. Bi means two. Tri means three. And poly means multiple. Now, the different parts or pieces of a polynomial are called the terms, just like we said. Now, if these terms have the same variables and the same exponents, we call those like terms. So they got to have the same variable, same exponent, exactly. So like, for example, the 2x squareds were like terms because they both got an x and they both have a squared attached to that x. The x's were like terms because they both had x's, but nothing else. It wasn't raised to any power. And the h would have been a like term on its own because there's nothing, it's a constant, there's nothing connected to it. Now, if the term has a variable, the number multiplying directly in front of the variable is called the what? Who remembers what that's called? So in other words, the number that's being multiplied to the variable, who remembers what that number is called? Coefficient, good. So that's called the coefficient. So for example, if you had 2x, 2 is your coefficient. Sit on my desk.
And the two rest were chance. Also, all boys basketball players were here with win. Please report to the video for pancake. Thank you.
All right. Now, if the term does not have a variable, so who knows what it's called when a term does not have a variable, a constant? So that's called a constant. Yes. No, they're just well, I don't know. They just said that it's like it's a surprise one, so who knows? They just warned us that it was going to happen this month, so probably, if I had to guess. All right, anyway. So a constant, another way you can think about constants is those are just counting numbers. So any number that you see on a number line that we think of when we think of numbers, those are constants because there's no variable attached to them. All right, so if we look at some of these examples, let's look at number one. We're going to determine whether it's a monomial, binomial, or trinomial. So what do you guys think about for letter A? What type do you think it is? It's a binomial. Why? Two terms. What about B? It's a monomial. Now, even though it has two variables, those variables are not separated by pluses and minuses. So it's technically considered a monomial. What about C? Trinomial. All right. Now, for 2, it's asking if they are like terms or not. So yes, they are like terms. No, they're not. So letter A, is 6x squared and x squared like terms? Yes or no?
Yes.
Yes. They have the same variable and the same exponent. Both have an x, both squared. What about letter B? Is 9x and negative 3y like terms? Nope. Not the same variable. What about 8x and 2x cubed? Nope. It's the exponent. This one's raised to the first power. This one's raised to the third. What about the last one?
Yes.
Yes. So even though it's written out of order, remember, multiplication is commutative, meaning you can change the order and it'd be the exact same thing. All right, so xy and yx are technically the exact same thing because it's the same two variables. All right, and they're raised to the same power, which is 1. So that's yes. All right. Now for number 3, we're going to list the coefficient and the constant. So for letter A, in this binomial, what number is the coefficient? 7. Why? It's the number connected to the variable. Good. What's the constant?
1.
1. Why?
Because it's a number that is not connected to the variable.
Yeah, it's a number that's not connected to the variable, or it doesn't have a variable. What about letter B? What's the coefficient or constant? -4. Is that going to be the coefficient or the constant? Coefficient, because it's connected to the variables. Is there a constant? No. So there's no constant. So we're just going to put NA. Now think about this carefully. -9. Is that going to be a coefficient or a constant? That's definitely a constant. There's no variable. So there is no coefficient. Now, this last one, there's more than one coefficient here. What are the two coefficients? 1 and 5. So there's an unspoken 1 here. And then we also have the 5. So or -5 actually. So what's the constant? 4 is the constant. Any questions on the basic vocabulary? All right. Now, a little bit more vocabulary. So, when it comes to polynomials, polynomials have to meet a certain number of specifications. All right. So, a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Keyword whole number. All right, so that means no fractions, no decimals. Well, as long as the decimal's greater than 1. So no fractions that are less than 1, no decimals, and well, actually, yeah, no fractions at all, no decimals at all, and no square. Oh my gosh. So, polynomials cannot have fraction exponents. It cannot have root coefficients. And it could not have negative exponents. So with polynomials, there's no square roots in it, there's no fractional exponents, and there's no negative exponents. All right. If they do have it in there, it's not considered a polynomial. All right. Now, we also classify polynomials by their degree. Oh, no, leading coefficient. Wait. Nope, it's degree. So we also classify by their degree, which is the term with the highest exponent. So the degree specifically is actually just the highest exponent. So the highest exponent is 2, the degree of the polynomial is 2. The highest exponent is 4, the degree of the polynomial is 4. It's 3, 3, 1, 1, 0, 0. All right. So a polynomial with a degree of 0, meaning it has an exponent of 0. So first off, let's say I had 9x to the 0 power. Anything raised to the 0 power is what? Not 0. Let's review for math 1. Anything raised to the 0 power is always what?
Is that always 1?
It's 1. So this is the same thing as 9 times 1. So 9. And we know 9 to be called a what? So we just talked about this. 9 is considered a what? Constant. Good. So if it has a degree of 0, it's considered a constant. So that would be 9, -2, 10, -1,000, whatever. As long as it doesn't have a variable after it, the degree is 0, and it's called a constant. I'll just put them on my desk. Now, if the degree is 1, so just for some examples, x plus 2, 3x, -4x minus 5. If you notice, the highest exponents on all of these is 1. Because if it's not raised to any power, the unspoken exponent's 1. Now, what type of functions do all of these look like? You've seen them before. What type of functions are these called? Same type. Basically, 90% of math 1. Starts with L, linear. So, if the degree is 1, we call it a linear polynomial. If the degree is 2, so some examples would be x squared plus 2x minus 3, or 2x squared, or x squared minus 4. So the highest exponent in all of these is the square. Now, these are called what we're basically learning in this unit, which is quadratic. And then finally, degree of 3. So that'd be x cubed minus 4. That can be 2x cubed plus 2x squared minus 5. So the highest exponent in all of these is 3. That's called cubic. And these are actually the function names. All right, so we define the function name by its highest degree. So all 4 of these functions are considered polynomials. So a quadratic function, linear function, cubic function. Now, a couple of other ones you may need to know. There's only 2 more. So if it has a degree of 4, we call that a quartic. And if it has a degree of 5, we call that quintic. I'm just telling you this just because it may pop up. All right, so degree of 4 is quartic, degree of 5 is quintic. All right, any questions on how we classify based off of the degree? Say it one more time. Up? Now, all polynomial expressions should always be written in what we called standard form. So, standard form means that the terms are placed in degree order. So, in other words, we use the terms with the highest exponents to the lowest. So, if you look back up here at the examples that I wrote out, I defaulted to writing them in standard form, right? Just because that's what I'm used to. All right. If you notice, like for example, this cubic function, it goes 3, 2, 0 with the exponents. So it goes from highest exponent to lowest. All right. Same thing here. It goes 2, 1, 0, highest to lowest. Up here it goes 1, 0, highest to lowest. All of these that I wrote out are in standard form. Okay. So you guys also defaulted to standard form when you were doing this warm up this morning. All right, almost all of you defaulted to it because technically you have learned this before. All right. So standard form isn't hard. It just, you literally write from the highest exponent to the lowest. Now, the leading coefficient is the coefficient of the term with the highest exponent. So for example, if I was looking at this cubic function right here, the leading coefficient is the coefficient connected to the highest exponent. So the highest exponent is 3. The coefficient in front of that x cubed is 2. So the leading coefficient is 2. All right. Right here, highest exponent is squared. What's in front of the x squared? Nothing. But remember, if there's nothing in front of it, it's not 0. It's what? 1. So the leading coefficient is 1. Now, one other thing that you may just need to write down. Leading term is the term with the highest exponent. So in other words, it's usually the first term listed in standard form. So leading term, and I'm dropping this because you may see this, leading term is the entire term. So leading coefficient is just a number. The leading term is the whole term. So for example, back to this example, the leading term is 2x cubed. All right, it's the whole term that you list first in standard form. The leading term here is negative 4x. So it's the whole term that we listed first. The leading term here is x squared, the whole term that we listed first. Do you have your pocket? All right. So let's do some examples. So first off, let's look at letter A. Is this polynomial in standard form already? So is it going from the highest to lowest exponent? Yes or no? What do you guys think? No. Why? What is the highest exponent? The 4. And where is it? In the middle. It's not first. So how do I rewrite this so it's in standard form? What do I put first? Negative x to the 4th. Then what? Plus 5x squared plus 6x. So whatever sign is in front of that term, when you rewrite it, you keep that sign with it. All right, so since this x to the 4th had a negative in front of it, we kept the negative with it. Now, Now that we got in standard form, what's the leading term? Negative x to the fourth. So negative x to the fourth is the leading term. What's the leading coefficient? So what's the only thing in front of that x to the fourth? A negative sign, right? So it's not just 1, it's negative 1. So remember, the unspoken, if there's nothing written in front of it, the unspoken number in front of it's 1. But if there's a negative there, it now becomes negative 1. Is there a constant in this expression? No. So we don't have a constant. What's the degree? So degree is the highest exponent. So what's the highest exponent here? 4. What would be the name of it if we classified it by degree? Quartic. All right. That's why I told you degree 4, degree 5. I told you to see it again. All right. So that's a quartic. Now, if I classify it by the number of terms, so that's monomial, trinomial, binomial, polynomial, what would this be called? A trinomial. So typically, when you name a polynomial, you name it by the degree and the number of terms. Yes, sir. Yes. So together, this would be a quartic trinomial. That's how you would name it. Quartic trinomial. All right. Now, if I look at letter B, now it's technically over 3, but what's true about all of these terms in the numerator? How they connect to this over 3. So if you see a fraction farther than a 3, what does that typically mean operation-wise? Division. So we're dividing by 3. Aren't all of these terms divisible by 3? Yes. So what we're going to do is we're going to simplify it first before we start classifying by dividing each of these terms by 3. So 15 divided by 3 is 5. 12x squared divided by 3? 4x squared. And negative 9x divided by 3? Negative 3x. So we haven't done anything else besides just divide it by 3. So this is what you should do before you start classifying. Make sure it's simplified to its fullest. All right, so combine like terms if you need to, do any division if you need to, or do any multiplication if you need to. All right, so is this polynomial already in standard form? Yes or no? No. So if I were to put it in standard form, which term comes first? 4x squared, followed by negative 3x, followed by plus 5. Now that we got it in standard form, it's really easy to see the rest of the classifications. So what is the leading term? 4x squared. What's the leading coefficient? The 4. Is there a constant? Is there a constant here? You sure? Yeah, there's a constant. What is it? 5. 5 doesn't have a variable, so it's considered the constant. Now, what's the degree? So what's the highest exponent? 2. So if I were to use its fancy name to classify the degree, what would I call it? Quadratic. Finally, if I was to classify it by the number of terms, what would I call it? A trinomial. There's 3 terms. So the fancy name would be a quadratic trinomial. So if I ask you to name a polynomial, that's what you should be asking yourself as you're naming it. What's the highest exponent? What's the degree? What would be the fancy name for it based off of that degree? And then how many terms does it have? What does that make the polynomial? All right, that's what you should be going through your mind when you're classifying polynomials. All right. So any questions on how we classify polynomials, the polynomial vocabulary, and finding pieces of polynomials? So like leading term, degree, coefficient, leading coefficient, constant, stuff like that. So again, you need to know this vocabulary because this unit is fairly vocabulary heavy. Okay. So especially the polynomial vocabulary because you'll hear it a lot with quadratics. Because again, quadratics are polynomials. We literally named the last one a quadratic. All right. Last thing we're going to do today is quickly talk about adding and subtracting polynomials. So we'll do multiplying on Monday. All right. Okay. All right. So adding and subtracting, you guys should already be fairly familiar with. We literally did adding for warm up. Okay. So adding and subtracting polynomials, very, very easy. All you got to do when you add or subtract polynomials is add or subtract the like terms. Which, tell me again what a like term is. How do I know if two terms are like terms? They should have what? Same. What are the words for it? There's two things for it to be a like term. Same variable, same exponent. All right, that's a like term. Same variable, same exponent. Now, biggest thing here, when you add and subtract like terms, you only add and subtract the coefficients. So that just means add dash subtract the numbers. Don't touch the variables. So that is probably the biggest mistake when I see combined like terms. Like if they saw x squared plus 2x squared, they'll give me 2x to the fourth. All right. Do not add the variables. All right. You're only adding the numbers in front of the variables. Now, you can either use a horizontal format or a vertical format. But you just got to be careful. So subtraction is the same as addition, but there's one extra step, and that extra step is you got to distribute the negative to the second polynomial. In other words, change its signs of all the terms in that second polynomial. So whatever the second polynomial is, you just got to distribute the negative, which is just the fancy way of saying change all the signs in that polynomial. So if a term was positive, make it negative. If it was negative, make it positive. And then finally, we will always write our answers in standard form. I want your answers in standard form when you combine like terms. That is the default. I want it in standard form. All right. Now, when it comes to combining like terms, I like to either use colors or shapes to help me determine where my like terms are. So when it comes to combining them, I just have to match. All right. So if you don't have colors, use shapes, like draw circles around one term, squares around another, triangles on another. All right. Whatever you're most comfortable with. So first off, before I start combining like terms or determining like terms, I'm looking to see if I have any subtraction. Do I have anywhere where I'm subtracting? Yes, I'm subtracting right here. So I want to get into that straight addition, meaning I'm going to go ahead and distribute this negative to that third polynomial. Yeah. So I'm going to rewrite this as 5 minus 9x squared minus 3x plus 5x cubed minus x plus 2x squared. The positive 7x squared now becomes negative 7x squared. The positive 2x becomes negative 2x, and the positive 6 becomes negative 6. So when I say distribute the negative, do not just distribute it to the first term. That's also a very common mistake I see. Make sure you change the signs of all those terms in the parentheses. So if it helps you, draw the line so that you remember to change the signs for all of the terms. Now, this is straight addition now. So what I'm going to do before I do anything is identify where my like terms are. So this is where you can either draw different shapes around them or use different colors. So can someone list me one set of like terms? Oh.
Negative 9x, negative 9x squared, 2x squared, and negative 7x squared.
Good. Someone else, name me another set. Rajan. Negative 3x, negative x, negative 2x. Someone else. Another 5 and negative 6. And then the x cubed, I'm still going to highlight a different color. It's just on its own. So if there's nothing to combine, you just bring it down. All right. So if it doesn't have a partner to combine with, you just bring it down as it is. All right. So we're going to add based off of standard form. So first off, I'm just going to rewrite my terms in standard form before I even add anything. All right. So what term would come first in standard form? 5x cubed. So I'm going to write 5x cubed first. What exponent would come next? The x squared. So this would be plus negative x 9x squared plus 2x squared minus 7x squared. What comes next in standard form? Would be the x's or the constants? The x's. So this would be plus negative 3x minus 2x. And then finally the constants, so 5 minus 6. Now, do you need to do this step every time? Not necessarily. I'm just doing it for this one so you can see how we're actually combining. All right. So if you actually look, I grouped it all by color. So here's my pink. Here's my yellow. Here's my green. And here's my blue. Oops, I forgot an X. Hold on. Minus X. Plus 5 minus X. There we go. Now again, do you need to regroup them? Not necessarily. But it is a good way to just kind of make sure that you're being consistent. Especially when you have one with a lot of terms. So now we can start our adding. So I have 5x cubed. We just bring that down. What's negative 9 plus 2? Negative 7. What's negative 7 minus 7? Nope. Negative 14. So this would be negative 14, and we slap the x squared on at the end. What's negative 3x minus 2x? Negative 5x minus 1x? Negative 6x. So we have negative 6x. And then what's 5 minus 6? Negative 1. So this will be my final answer. So this is my answer. I'm not going to rewrite it. What's the degree of this polynomial simplified? What's the highest exponent? 3. So officially the name would be what? Cubic. What's the leading coefficient? 5. Now, that was the horizontal way. That's the... All right, so back along that back wall. All right, does everyone have a seat? Absolutely no talking.
standing classroom until the principal announced it. Thank you.
So when done, we just gotta stay in the rules or something. Alright, so. Alright, so I'm gonna go back to your seats.
I forgot about crowd.
I'll send it there out.
Alright, I need to explain it.
Alright, so no one's leaving the room until Dr. Holt announces that.
Yeah.
Well, I guess he's still there until they announce it's over. All right, so that was the horizontal way. So the vertical way is pretty much the same thing, except what they do is that if you notice, they line up the like terms. All right. So this is a subtraction one. So first off, if I want to change this, I have to distribute this first. So I would make this a plus. So this negative becomes a plus. This becomes a minus, and then another plus. And then I just add, like, back in the day when y'all were in elementary school, how you would add, like, vertically. That's basically what we're doing. So what's 5 plus 4?
9.
This would be plus 9. What's 0 plus negative 2n? Negative 2n. So if there's nothing there, you can always put plus 0 in, however you want to put it, just so you know it's there. And then 4n squared plus 2n squared.
6n squared.
6n squared. And that's it. All right. So this is our answer. What's the degree of this polynomial? The degree. 2. Leading coefficient? 6. All right. Last example we're going to do that I'm going to have you do on your own. So it says find the perimeter of a rectangle whose length measures 2x squared minus 3x plus 6 and whose width measures 3x squared plus 2x. So perimeter means what? Add up all the sides. So if we have a rectangle, one side is 2x squared minus 3x plus 6. The other side is 3x squared plus 2x. What's this side? The 2x squared minus 3x plus 6. And what's this side? 3x squared plus 2x. So you gotta be careful with this one because you actually have to rewrite both expressions twice when you're doing the perimeter. All right. So if I write this out, I have 2x squared minus 3x plus 6 plus 2x squared minus 3x plus 6 plus 3x squared plus 2x plus 3x squared plus 2x. So I'm just going to go through and highlight all my like terms. So it's one set of like terms. You can just tell me what the variable is. The x squareds. So 2x squared, 2x squared, 3x squared, 3x squared. What's another set of like terms? The x's, so negative 3x, negative 3x, 2x, 2x. And then finally our constants, which are the 2 6's. So what's 2x squared plus 2x squared? 4x squared plus 3x squared? What's 4 plus 3? 7x squared plus 3x squared. So this would be 10x squared. What's negative 3x minus 3x? Or what's negative 3x plus negative 3x? Negative 6x plus 2x? negative 4x plus 2x.
Two X.
Oh, yeah, negative 2x. And then finally, what's 6 plus 6? 12. So here's our answer. So this would be the perimeter of this rectangle. So don't get thrown by a problem like that. It's actually really easy. It's just a combined like terms problem. You just got to make sure that you add both expressions twice. So what's the degree here? Leading coefficient? Good. All right, take a minute. Try number 4 on your own. So just try number 4 on your own. Thumbs up if you're ready. Just one more minute. All right.
Good morning, West Carteret students. This is your principal, Dr. Holt. Just making an announcement as a reminder, in February, we do focus on student safety with district-wide school lockdown drills. Today, we conducted our lockdown drill. It was successful in partnership, of course, with our law enforcement partners at Moorhead Police Department and our school resource officer. We appreciate your support in reminding peers and yourself about our expectations for a safe learning environment. Have a great rest of your day. We will, of course, remain in class until the end of first period, but at this time, our lockdown drill is concluded. Thank you.
All right. Check your answer.
Staff, this is just a update that you may receive a second alert on our Rave app. So do not be surprised. That is also part of our drill and testing of systems. Thank you.
All right. Any questions on that one? How'd you guys do? All right. So we're gonna stop there for today. So your assignment for what we've done so far, there is a 3.1 Delta Math, but it covers all of 3.1, so that includes the multiplication. But you can at least knock out a good chunk of it. All right. You don't need to do the multiplication part yet. I mean, obviously, if you want to do it, you can, because you should already be familiar with multiplying. But it just gives, at the very least, get through addition, subtraction. All right. Now, don't forget, this Delta Math is not going on this term. So I don't care if you have to prioritize